So this life will be special a bit more because first of all, let me check. Seems I am live. Am I? Hmm. Hello. So yeah, what I was saying is this life will be special because we'll not only cover, whatever this lifetime is inside these, 9 topics, but I want to start my this life with an idea. Well, I got an idea to why not create something like I've heard about these projects multiple times. Like cybersecurity expert did find out some vulnerabilities, like they could use Wi-Fi as a radar to track if there are people who are breathing and all, uh, and their position with respect to the router and all that. So I thought, okay, why not we try, creating it, and we'll be doing it using, mainstream calculation using using Rust, and just, user interaction, like me interacting with that app using Python. So I asked GPT, and it said it is possible. So I am set out to, find out how much truth is there and how much is not. Like, can I try it? Can I not? Is ChatGPT just giving me false hopes and all that? But let's try. So, what is the core idea? That we will create, first of all, a Rust part of this project and Python part of this project. Python part will be mainly about, projecting it in a graph or some 3D simulation if possible, but graph is all right. As for Rust part, it will, do something RSSI using, you know, so it'll do all these maths that is required to plot that graph, and Python app will just, use the data from Rust and will try plotting it using matplotlib. All right. So it says now we create some project directories and all that. So let's copy paste so that we don't miss a name, we don't misspell a name and all that. So we are under project directory. Let's create Rust core and Python app, both project directories too. All right. And now we should have, yeah, Rust app and Rust core. So I'll try, speaking less for this project because, well, I am also curious and I also want to see where we can go with this. CD Rust, well, if you're a beginner, you should know CD is change directory. I don't want to speak right now, but I should actually. We are initializing a cargo, which is, Rust. Uh, but we are saying that we will be creating library, not binary. So this will be a library. We know what is the difference between library and binary. We know that a bit. So cargo terminal has been initiated. Let's see what is there in the cargo terminal. Ah, exactly something like this. Now dependencies are not there. Oh, C becomes something like this. Did it? Let me see. Yeah, it is exactly something like this. Whereas we have cargo.toml and in SRC we have lib.rs. Nice. So, what is the main thing that we are trying to achieve using this project? It is to see how we can combine both Python and Rust. Like I have never in my life combined two languages together for just one single task. Now I am doing that. Like I've used libraries like NumPy and all that, which combines C and Python, but never have I made my own thing, my own APIs, my own libraries to be used using some other sort of app or language. Now, stage 3 is to edit cargo.toml. Well, I think for editing part, we shall do it without any sort of mistake. So, this is not a experimentation. This is just sort of implementation that we are trying to see if possible or not. So, package is still there. Dependencies, well, we'll delete these. All right. So now it becomes what is it? Where did I invoke this manifest format? All right. So that I can, you know, check whether both of them are same. Well, they should be, except for the addition. Doesn't matter. All right. We'll save it. Quit it. Now stage 4 is that it's saying create Rust files, which is filter.rs and FFT. So we'll touch filters.rs and FFT.rs. Inside SRC, first of all. SRC, we'll say touch filters.rs. Oh, filters.rs. Let's see if there is S in filters. Exactly, filters.rs. No typo. And then FFT.rs. All right. Shit. Well, things happened. Exactly the same tree that the GPT has been expecting from us. Same tree. Now in stage 5, we have to write a filter.rs. So filter.rs first of all has pio3 and some prelude. Pio3 is a library, I guess. We are using that. And then we are creating a pipe function which is EWMA. And then we are calculating EWMA, and then we are passing or giving out the result. So let's do that. SRC filters.rs. We are pasting it. If you want to see the code, well, here it is. We're creating a py function, so I guess we can access EWMA from Python. We are using pyo3 so that we can make a library that is compatible with Python. And in function EWMA, we are passing out signal, which is of type vector f64, alpha, which is f64. So this is just a float number, whereas this is a vector containing multiple float numbers. And the return, which is the result, will be of type vector f64. So this will be a pointer or vector. Now we have a mutable result, which is, well, getting the signal's length, this vector's length. And then we have a mutable previous, pref, which is, well, initialized at signal 0. And then we are saying result.push, whatever that result is, push it to prev, which is this. And that's what we are trying to do. And then we are taking that previous in the loop for a reference of x. What is x? I don't see x. So x is in this whatever the signal length may be, or the last thing it may be. So for all these x, like starting from 0, 1, or whatever, signal 1, what is there in signal 1? I don't know. But we are multiplying it with alpha, which is a number that pass for. And then we are adding it sort of 1 minus alpha, the number we are passing, multiplying it with previous. And then we are pushing previous again so that previous gets updated from signal 0 to something else. And then we are passing the result. I think it's clear. I think it is. So let's go to, well, stage 6, which is, create FFT.rs. Copy it. Well, why am I not coding it? Because I don't want to experiment with my typos, because I know I will make some typos and I'll know that I have to debug it. I just want to quickly, sort of see the integration between Rust and Python. That's the result I want. Well, PyO3 prelude, and then Rust FFT, which is FFT planner, and Rust FFT. Oh, so there are libraries like Rust FFT and IO3 is there, we know. But Rust FFT has FFT planner, num complex. From there, we want complex. I don't know what it is doing, but all right, all right. Let's move on. And it says modify the lib.rs, replace the entire file with this. So there must be something in lib.rs first of all. We should replace everything with the given code. Exactly, there is a test. So let's open up a new line, paste all the code, which is nothing but Wi-Fi core is a function, and then wrap function of EWMA and FFT power. So we'll access in Python something like Wi-Fi core dot EWMA or FFT dot power in Python, I guess. That's my guess. Okay, best of my guess. So how many lines do I want to delete? I want to delete something like 13 lines. So is it similar? It is. We'll save it and exit. Now stage 8 is to, compile Rust module for Python. Now I think it will sort of install things too, like all these dependencies and all. So we have to say mature in develop release, and it might take a bit more time. Mature in command is not found. Well, did it give us any sort of instruction? Mature in is there, is not. How should I install it? Hello. Yeah. So it is. So we will try to, create or install all these, libraries. So how to create virtual environment in Arch? Well, you say Python, free, then dash m, then venv is there. And we should name it exactly venv. We don't want to think about naming and all that. We can create my venv using, changing the last one to my venv, something like that. My virtual environment. And it will take some time. Well, it has taken some time. Unless we have venv. How to activate this venv? We'll go to source and we say venv. Inside that we have bin. We have to activate. Well, we activated. Now we see there is a venv activated. Now we'll paste all these pip install maturin, numpy, matplotlib, scipy, all that. It might take some time. So let's wait and see. Till then, let's see. We were at our compile stage. We were sort of compiling it. Maturin develop release. Inside Rust core folder, run this. This will compile Rust and install a Python module called Wi-Fi core into your Python environment. So it says into your Python environment. It means our Python environment should have been activated to do this. Yeah. I think we know where the compilation error might have came from. And then we'll create a stage 9 where we'll create Python test core.py, and let's write it first of all, from here. Well, how about, we wait for a few minutes, but let's see the whole idea. After writing Python, which is testcore.py, we'll run it using Python only. So Python and Python app, then testcore.py. That's how we run a Python app. And you should see a signal plot, filtered signal, FFT spectrum. Now, this confirms that Rust and signal processing plus Python visualization works. After this, next stage will be to build a real RSSI detector. So this is not a real, this is just a, demo sort of that Python and Rust works together. That's, well, really what I want to know. As for RSSI acquisition and filtering and all that, well, important, but not much because we are just learning how to use both of them together. As someone is very, interested in this project, well, they can go with their own sort of questions where they, well, just use Python because it's very easy to prototype the apps on. All right, so I'll not wait now. So I'll open up another terminal where I'll first of all go into my directory, and then over here I'll open up Vim named as uh, testcore.py. No typo? I don't think so. Beside that, we have to paste this. Well, don't run it. We paste this and looks great. Save it, get out of it. And now we shall see R3 somewhat like this. Hmm. Well, why is the tree something like this? Because we are installing all these libraries. So yeah, that's what to be expected. Well, it's first of all downloaded NumPy, then matplotlib. Now it's downloading SciPy. I've never used matplotlib, honestly. As for SciPy, well, that too. As for Mathurin, well, it is very new to me. It is sounding new to me, so. Once you finish stage 0 to 11, what is the 11th stage? Running it. But I have not completed the stage where I compile it. I did not complete stage 8 and then stage 11. So 8 and 11. How about we closing this terminal? Only one terminal should be enough. And what you are seeing over here is, well, this is my terminal. Whenever I shorten it, it somehow, renders the earlier one useless and then starts making a new one. So matplotlib has been downloaded, which is 9.8 MB, you know, and this has been sort of stuck there. It's useless, but it's still stuck. It is, well, some rendering problem that I can't figure out. I'm using Arch Linux, so yeah, obviously we have to figure out everything. But still, it's workable with. You can work around with this. That's why I mostly don't use two terminals together. in one workspace. If I have to use two terminal, I'll go to a well newer workspace. I'll open up a terminal and it works fine. But two together, not so much. Well, since I'm live streaming and all that, that's why I think the internet is very slow. So if you're watching this, well, just try skipping it. Why are we downloading a font tools? I don't know if it is somehow, related libraries, dependent libraries or something like that. But I don't think we said it download font tools. I just copied and pasted this, which had three things, I guess. No, four, which is Maturin, downloaded, NumPy, downloaded, Matplotlib, downloaded, nice SciPy is also downloaded. SciPy is downloaded. Where is it? SciPy is downloaded, 35.2 MBs. Now we are downloading some Contour by Cycler font tools. Kiwi solver. Well, do we need it really? I have not said it would be downloaded, but it is. And it says Maturin is required to compile Rust into Python modules. So, yeah. Dependencies are PyO3, Rust FFT, NT array, which is sort of NumPy's array, but Rust format. This is not a NumPy library, but it does exactly what NumPy does to Python. But ND array is very native to Rust. Rayon, I don't know what Rayon does. Matter and develop, release. We'll just get downloaded. Now it's downloading below. I've got below. Below is used for, I guess, I have used for image generation. Below. Six bypassing below. Oh, so now it's really installing it on system. All right. So it's going to end soon. Ah, so everything has been downloaded. Uh, let's check it again. Now it should run very quickly. It ran. As for pip install upgrade pip, we'll do that, but not exactly here. We'll do that in our fourth workspace, as I've already said. Pip install upgrade pip. Ah, that doesn't work. I guess we should do something like sudo pacman.s and python pip, isn't it? Pcp2 pip. Let's check it. Python pip, exactly. So let's do this. Well, now it has installed 26th version. All right. Now, if anybody would create a new environment, they'll get a updated Python virtual environment. Now, since R3 is ready, how about we just do dash L. Tree dash L, we have two. So we have Python app, we have Rust core, uh, SRC has something, and then we have, well, virtual environment. How about making it three so that we can see some things? So we have Python app, Rust has SRC, which has FFT filters and lib. As for target, we don't want to see target. VNV, we don't want to see VNV also. So now we should go into Rust, which is our step 8. We have to complete our step 8, which is this. We have to run this mature in develop release, and this will compile a Wi-Fi core, sort of. Why? Because, well, our name of this library is Wi-Fi core. All right. So if I run this, yeah, now it's creating. Now this will also fetch these libraries and dependencies. We see our first error that failed to build a PIO3 FFI and exit successfully, which is all right. STD out is if environment changes PIO3 cross and all that. Standard error. The configured Python interpreter version is 3.14 is newer than PIO3 maximum support, which is 3.12. Oh shit. So I think we have to somehow, go to Python 3.12 version. Do we have a Python 3.12? Python 3.12. Do we have this? We don't have 3.12. How about sudo o? So in step 8, we faced sort of this error. So we'll say step 8 has this error, and we won't specify which error, but I think it is because of Python, which is my latest Python 3.14, and go. So this is the sort of error that you have to go through when you are on the latest sort of environment and Pythons. See, I used Python 3.14 instead of 3.12, and Pio just gave out. See, exactly, it found out that Arch Linux recently moved to Python 3.14, which breaks the older Pio3 version. There are two solutions. Correct long-term one. All right. So it says upgrade Pio3 version. We will upgrade Pio3 version that supports Python 3.14. So we'll open up the cargo.toml. Inside that, we'll replace this dependency exactly to this, and we'll save it. So let's go. That's why we should always version log our, oh, there is a version log, but dependencies a little bit. Let's clear it out. Let's go to cargo.toml and in dependencies. So we have a rayon nd array, rust fft, pio3. So all these 4 things are there. Just a version changed from 2.0 to 0.28. All right. So we'll delete these. And we'll close it. So we did it. Step 2 is, well, we have to clean everything by saying cargo clean. Yeah, it cleaned the, target file. So it'll have to compile it again. This removes the old incompatible compile artifact. Now we run this mature in develop release again. Let's clean it for a very dramatic effect. Let's see. Yeah. Well, I love seeing projects getting compiled. Hmm. Found three bindings, no errors. Good for us. After creating all the C Pythons, we have to, you know, sort of verify if whether Python can implement our Wi-Fi core library that we have created just now. All right. And if it does, we print module has been loaded. Nothing like that. Then we exit from it and well, well, I checked out because of this error. Exactly. What should happen next? Once Matterton develop works, then run our test code for .py that confirms Python visualization and Rust signal processing. After this, next stage will be to build real. So this is the real command. IW is sort of, network configuration. From dev, we go to WLAN 0, which is sort of, our Wi-Fi device, if it is there. Sometimes it's 1, it's sometimes 2. So WLAN 0, WLAN 1. We'll check it out. We'll press tab so that it enters it again automatically. Damn. Shit. We get another error, which is this. It says, so I think this is because of all the copy paste functions that we did. So there are some errors in the function. So let's go paste it out. So I think now this will have to edit our libraries or some other files. We'll have to do this. This will take more of a time. See, now it says edit our lib.rs. Open this file, replace entire code with this. So our fix step 1 is like this. We'll create a new lib.rs. Let's clear it out first of all. Using cat command, we'll do this. All right. We'll go to src, lib.rs, whatever is there, I don't care. We'll just print a new one, give it a line, control D. Now, yeah, it's done. All right. So this is a write sort of function, like we use write in a Python, no? And if we wanted to use append, then we would have used two sort of these arrows, but we'll just write it out from new. Now it says rebuild, so we have to again cargo clean, install everything. Shit. Now it seems so that I don't like just compiling. I compile successfully. If it's failure in compiling, well, I hate it. Absolutely hate it. I think so that everybody else also hated it. That's what happened. It is now compiling Rust core. I think last step. Just compile it. Well, if anybody wants to know, my CPU is running wild, like 97, 98, 100%. Yeah. Why? Because I'm live streaming as well as, compiling this. And I am on low end. And well, it has compiled. Good for us. Since it has compiled, we'll have to verify by importing it. Oh, not this. So we'll just say Python and we'll try importing it over here and we'll press enter. And yes, we do import it. If we can import it, how about not just doing this? Oh, quit or exit, isn't it? I have to say exit. Yeah. I have to run the Python. Let's go and copy it out. Hey, how about just writing it out? Python. Oh, first of all, CD. Now let's run python Python app and testco.py. Let's see. So this is not an error. So it sort of ran and gave us a warning that figure canvas argument is non-interactive and thus cannot be shown. So plot plt show cannot run successfully, but I think this has worked out. Now we have to just create. Now it's explaining like why this error happened. So there was old API which was using module and this, which is mpy module, and new API uses this like, well, I don't know, but something like this. And this ensures the memory safety with Python's GC. Well, first of all, let's do this. So I think this was just a demo, so therefore we did not use an interactive sort of canvas argument. So that's why this could have happened. But let's see what our GPT has to tell us. So good, the Rust module compiled correctly. The warning you see is not a code problem. I know it is a matplotlib backend issue. So the environment you're using, the AGG backend, which cannot open window. This usually happens when running inside virtual environment without GUI backend. Matplotlib default backend is AGG. We just need to switch the backend. So install GUI backend. Okay. So we have to install few things again. TK is for Tickinter, I guess. Tickinter or something like that. Oh shit. Let's well just clear it out. And again, it's installed. So there will be no locking issues. TK is Tickinter, which is used for, creating interactive Python sort of apps. That's all I know about TK. And I've created, buttons and all that using Tickinter. So it was very earlier on. Then I moved on to web development and then integrated that with Python. So then, creating beautiful React apps and the backend was running on Python. So I didn't use Tickinter very much for interactivity. So we installed it. Now we have to reinstall our matplotlib. Let's go and do that too. Now the another fix is, just give it an argument to use tk agg instead of just agg. So let's copy this and we'll paste it using cat argument. That's lovely. Not append, like this is for append, this is for write. Now we just have to run Python and whatever is this. We run it and we see some signals, some outputs. All right. And my CPU is spinning up. Well, I want to sort of screenshot this and give it to a GPT. I just have to say, there is the result. RESULT. All right. Then let's first of all sort of close this app. That's how we end it. And the next thing that I want to do is run this command iwdev. Well, I also want to see, am I using volen 1 or volen 0? L IW command is not found. Damn. Do I have to install IW? Shit. Why I am very familiar with IW? Because I've installed it previously. And I guess then, while installing the while installing the Arch, you just get IW to connect your Wi-Fi. So I've used IW, but somehow after installing sort of Arch, we get a network manager and which is something like NLW, something like that. And network manager, so NMCLI. All right, NMCLI. Yeah, so this is it. You can see these are all the things. NMApplet. This is NMApplet, which is I'm using it to sort of connect. NMCLI. This is the thing that I install after Arch, so that I can manage my network quite easily. IW was always there. If it is not, we can just install it. That's what I thought. Shit. Now this is a rendering issue in my terminal. So let's type it out. Sudo pacman-s and what is it? IW, no? Now again I have to say IW and then I have to say dev and there is no tab completion, so well, that's bad, but just this much. Interface is WLAN 0. Good. Now we have to run iwdev WLAN 0 link, something like that. So we'll do that. IWREV and WLAN 0. Yeah, there's no tab completion. 0 and then link. Well, expected output is something like this. Exactly it is. So the important line signal minus 47 dBm. Where is that? Minus 38. So see, this is signal. So we'll be using this signal. Now it says the project tree will now expand. So Python app will expand now. So create the files, we will. But before that, oh shit. So it gives me the code for RSSI reader. Well, remember that because now we have test core and RSSI reader as for liveplot.py. We don't have that yet. And as soon as we run this RSSI.reader, we should get RSSI of minus 45, 46, something like that. So how about we do that? How can we do this? We'll copy this. We'll use cat, I guess. Or should I use vim? Cat is there. So we'll say I am going to write a new file. Shit. ls rm import. We removed it. ls python testcode.py. About I define something like Python app. Inside that, instead of testcode.py, we want RSSI reader.py. RSSI reader. READER dot py. And now I have to paste this. Let's paste it. Now we have to run it. Clear it. And now we have to run it. Python and RSSI.reader. No such devices. So let's see first of all. Well, clear first of all, and then let's see what sort of device are we talking about. Did we write something else instead of WLAN 0? So we'll search for that. Yeah, interface is not this. Change this. So it says change this. So we'll change it to WLAN 0. Did it suggest me? WLAN. I think it suggested me. I'll take it. Then everything works. I don't have to change anything. Now we'll try running. Where was it? Where was the Python? This. We have RSI of, all right. We'll close this. And we'll sort of copy it. And we'll paste this result as well. Excellent. Everything is behaving exactly as expected. So output is shown good. Those sudden drops, like, there's no movement, but still there are sudden drops. So yeah, something like minus 51. Sometimes, yeah, so there are some disturbance, but these definitely are not human motions. Let me clarify that. Stage 3 is something like real-time Wi-Fi motion detector. So we'll create a new program that, first of all, RSSI stream. It takes that and make a rolling buffer, then Rust EWMA filters, uses now Rust library that we have created, and then creates a variance motion score and gives us a live graph. So, all right. So I'll try moving, but first of all, let's create it. Project tree after this step. So we have to create motion monitor.py. Yeah, it says create motion monitor.py. Let's copy this. See, I'm copying it. All right, and let's do using cat because I love cat. And now just paste this. Paste it. Give it a new line. Exit. And it has been saved. Now I have to run this from project root. Well, I am at project root, and now I have to run this. I'll run it. Well, it runs and screenshot it. Yeah, now I'm moving well back and forth. There's a lot of movement, and now I'm sitting still. Yeah. So if I sit still, well, this is quite interesting now. This is quite interesting. As for this motion score, I don't know what it's doing. How about I go for a walk? Well, still doesn't capture much, but we are happy because we have integrated our Rust and Python app. So we are very happy. Now let's interfere with it. We have interfered, and now just paste observation. Why this works? There's a router, there's wall, but there's not much of a router. I am using my well phone as a router. So yeah, signal, well, it was just, so it says next stage much more powerful. We'll add Kalman filter, Butterworth filter, multi-feature anomaly detection, FFT breathing detector, real-time radar style plot. So breathing detection, not yet. Well, presence detection is very rough. Room activity spike, it is there. Human movement, I was moving. So yeah, motion score is 1.45, which means the system is detecting by variations. You are using your phone hotspot as router is completely fine for this experiment. In fact, it can sometimes produce a stronger signal variation, which helps detection. However, we should make two improvements now because RSSI from a hotspot is noisy. Add real motion threshold and show the motion events clearly. Stage 4 is, well, we have to modify this file. That's why I use cat, because now I can just save and cat this file exactly same, and now we'll just paste the improved version, which is this. Seems long, and we'll have to run this again. We'll paste it, we'll save it, we'll clear it, and now we'll run it because it says so. Motion detected, motion detected. Oh, well, I am not moving now. Shit. Let's run again and we'll take a screenshot of it. And that's it. Well, take a screenshot. Yeah, now I'm not moving, so no motion has been detected. That's good. That's good. Now suddenly it is detecting motion. I don't know how, but suddenly it is too much. So let's close it. Let's paste it. So sometimes it's working, sometimes it's having too much noise to even work. So it is something like, filters, more filters, some motion analysis, and we'll use multi-threaded processing for, calculation in Rust. Then radar style visualization, a circular motion heat map. Well, now this is getting interesting, but as soon as times is up, I'll just remove this sort of project. One quick question. Your signal range is 32 minus 45 dBm. That means your phone is very close to the laptop. Yeah, exactly. And for better motion detection, try something like distance between phone and laptop of 3 to 5 meters. All right. I'll give it a... So now it has a difference of 1 meter. This increases the multipath reflection, making movement easier to detect. Okay. If you'd like the next step, you can turn something much closer to the story. All right. So well, if anyone is seeing me, tell me if this project is near completion. Is it good? Is it bad? What happens next? Well, my screenshot shows that there's a motion detected, and the graph motion score is 0.80, or your threshold is 2.0. So if the threshold gets to 2.0, it says motion detected, but if it is less than 2.0, it says no motion detected, something like that. And fixes that print motion only when state changes. I don't want to do this. But before that, it has given us a task. Well, we have to replace a while loop with this version. Let's see. Now we have to go Python app. What was it? Motion detector, isn't it? Inside that we have a while loop. Which one? This is also a while loop. So this one. Yeah, exactly this one. So before editing or deleting it, we'll first of all insert some dashes, and we'll make those dashes as comments. We'll get to the end. We'll create some more dashes, and we'll paste it. A new while loop. So last motion state is false. Well, a new variable, and then we use something like same thing. While true, do these stuff. I think we can either delete these, or what should we do? Should we delete these? 20. Oh, EPJ. Somewhere more, so 14 DJ, and some more like 5 DJ. Let's do 4 DJ. Just do a DD for this. Save it, clear everything. And we have changed a loop. So let's run Python again. So no motion has been detected because I am not moving. I am moving now. Yeah, so motion has been detected. Now back again, I'm not moving. Will it go back to normal? It is not. Well, trying to go back to normal. So yeah, it is there. But it's giving us some spikes, more spikes. I think we'll conclude this project. It shows that motion has stopped. Let's take the screenshot. Motion has stopped. All right. So even if there is a small motion like speaking or breathing, or even, moving a mouse, it somehow changes this motion scope. So like I am not moving my mouse anything. And now I am. So my body is moving now. So it is increasing. See, it gets increased. So I think it's working, but with a bit of lag. But this much of lag is, all right. Now motion has stopped, obviously. Yeah, I sort of moved my hand to explain, obviously, but yeah. Did I breathe too quickly? Like, what is happening? It is interesting. So let's take a screenshot and paste it. And just say yes. So whatever it's next, it'll give us the instruction. As for now, well, my CPU usage is good enough. What is this home? I see some home. Some tinkering things. Next upgrade would be Butterworth filter and Kalman filter. Well, important thing to note over here is I am not even coding. I am just trying to understand. So, well, I think GPT is getting smarter and smarter. So it's better to learn from GPT rather than just extracting its value. So my pipeline is now stable. Phone's hotspot is there. RSSI sampling we are using Rust EWMA filters that we have created. We have a variance motion detector and then state change events. Well, should I or should I not publish this project as my project, or should I just make it like a vibe coded project? What should I do? Well, stage 5 is add Butterworth noise filters. Well, first of all, we can improve this as much as we can, then we'll publish it. Right now, you only use something like EWMA smoothing, but a Butterworth low pass filter removes the noise much better. So it tells me the pipeline will become something like RSSI, that is from Python. We'll go to RSSI is from Python, no? LS Python. Uh, RSSI reader. So from Python, it goes to Butterworth filter. Then it goes to Rust EWMA instead of just directly going. File structure will differ. No new files needed. We only modify monitor motion monitor.py. It says add this thing. Step 2 is add a filter. And step 3 is to modify the processing pipeline. Replace this part, which is filtered Wi-Fi core EWMA, with this part. Good. So since it's telling us to change things, we will. So let's get started from step one, and we'll use Vim for this, not cat, Vim. So let's do Vim, Python, and then motion monitor, not py. It says print this. So I think, yeah, exactly same. Step two is to add a filter function. So this is a filter function. So I think I'll define this filter function sort of at the top or over here. Let's do it over here. Let's create the filter function, give it some space. Oh, it's already in insert mode. Low pass filter. This is a filter. Give it a bit more space. Then we have to modify this filter. So let's see, where is it? Yeah, over here. So we have to modify this. Yeah, it's only there. So we have to modify this. Yeah, I don't see filtered anywhere else. So let's GCC it. Oh, shit. GCC. Let's get a new line. And we'll add this line. There's some indentation problem, so we'll indent it properly. Now there's no indentation problem. We'll close it. Final signal pipeline is, now the code does something like raw RSSI goes to Butterworth filter, then Rust EWMA filters, then variance motion detection. This will reduce false detection by 50 to 70%. Run again and see this for your build. Next upgrade. Should we do this? Should we take this new upgrade? So it says make the Butterworth filter into Rust. So we'll do that. We'll do that. Before that, let's see if our monitor not by works or not. See if it works. It works. So nothing as much changed. I'm not moving. I am moving. I was moving actually. And now back again, I'm not moving. So now it's detecting quite, well, I would say, accurately. Now let's close it. I don't know how to close it, but I did close it. So let's move on to creating Kalman filters. As a Butterworth filter into Rust. Should we do this Butterworth filter into Rust? Yes. Uh, we will do Butterworth filter in Rust as well as these filters, because I am not coding right now. GPT is. Oh, my CPU is lagging right now, like too much. See? Good plan. We will implement 3 upgrades and clean pipeline. So everything mostly in Rust, just the last one, which is Wi-Fi radar heat map, which is in Python for visualization using matplotlib. After this upgrade, your system becomes a proper RF signal processing pipeline. Final architecture would look something like this. We are getting RSSI, then we are using Rust Butterworth, Rust Kalman, and Rust EWMA. Feature extraction is Python radar heat map. And I guess we have to update, what was it? This file, motion monitor, because we have defined a Butterworth inside the definition. So yeah, we have to upgrade that file. So step one, it says update project tree. Your project tree will look something like this now. Let's see. Let's see if exactly it's how it says it is. Rust core, and I want dash L to something like 3. So SRC has these 3 FFT filters and lib.rs. Now it says lib filters and FFT. After that, we have butterworth.rs and Kalman.rs. All right. And Python app doesn't change much. All right. So Python app, it doesn't change much. PyCache was, well, don't see this because that's already created automatically. Motion monitor, RSSI reader, test core. So it doesn't change much. We don't add new files. We do. Motion monitor is there. Radar monitor is there. No, it is not. RSI reader is there. So we remove this test core.py and we add a radar monitor.py. All right. So let's do this. As for test core.py, we'll make it a backup. All right. How about we move Python app test core.py to the same place, but we add a dot back. So this is not Python now. This is a backup file. Now we ls, we see that tree for Python, and it should have changed. See, now we'll create something like, so we say using Vim, let's use Python. And inside that, we'll touch a new file with radar monitor, radar monitor.py, radar monitor.py. We have touched it, so radar monitor.py. No errors. As for Rust, we have to create these 2 files. So, well, butterworth.rs, and so let's copy it. Let's paste it. Well, my CPU is lagging, hacking, whatever. Got it from here. Now inside SRC, we'll say touch these files, so you can create multiple files using touch. And now I think our tree is fine. It's just we have to create those files and code it. So butterworth.rs will look something like this. All right, let's copy it. Well, this project is still very functional for what it is. Butterworth.rs, and we are using Pio3 prelude and Butterworth, which is taking signal. It looks very familiar to me. Let's see. Oh, not this. Shit. Well, what I wanted to see was in SRC. I want to see everything sort of, yeah. So this is EWMA. So EWMA was using same, signal and alpha, and Butterworth is also using the same. Where is our Butterworth? Uh, so F50 only used signal. You're seeing it. And this is a Butterworth. It is same as EWMA. You know, same. So what's the difference? Even the formula for filter is nearly same, isn't it? It is. And we are pushing filter to previous. So what is the difference between EW Butterworth? I don't know. This is a fast IIR low pass approximation of Butterworth response. Okay, this is just an approximation. Now we have to create a Kalman filter. So Kalman filter is this. Now this looks different using signal and Q and R. Q and R will be both F64, which is float. And now this looks interesting. Let's go. We'll say Vim and Kalman.rs. We have Kalman signal QR X is signal 0, which is initializing X with something. P is 1. Again, initialize P with 1. And we will be changing P because we have created mutable X and mutable P. Now we have mutable result, which is taking vector with capacity of signal dot whatever the signal dot length. Then we are pushing X, and we have for shit. All right. Explanation is this, that X is an estimated signal, P is uncertainty, K is Kalman gain. So the filter tracks the real RSSI state. The step 4 upgrade is, we'll upgrade our lib.rs. So replace with this. So this will be our new lib.rs. So we'll use cat for delete and all that. I don't want to do that. Cat and we say lib.rs. We paste a new lib, get a new line, end it. Now everything is sorted out. Now we have to again and compile it back again. So we'll go back. Are we there? We'll clean it up. What's next? Let's see. So step 6 would be to create radar visualization in Python. Kyle. Yeah. So everything is compiled. All right. After that, you have to create radar monitor.py. We have touched the file, so we just have to paste it. Let's go. CD, bit more. We'll open up Vim. We'll say Python and radar. RADA. Oh, there are two files. Radar monitor. We paste it, we close it, go back, and this time we have to run radar monitor.py. And we will do that, but yeah, we did compile a new library, so no buts, no ifs. Yeah, it is there. And what is this? I don't know actually. I am moving back and forth, so yeah, now I'm stable. Let's print the screen. Let's paste it. And instead of seeing something like this, I'm seeing, gradient of colors. Now I'm moving again. Will it create yellow? Well, there is a movement. Will it create something? Well, nothing. So I don't think this is working much better. Ah, there are some influences. Oh, damn, damn, damn. Shit, shit. So it's slow, but it is there. All right. How to exit this program? How about I just interrupt using keyboard? Yeah, this is the easiest way, but not the safest, I guess. We can push it further. If everything is fine, then let's do it. Let's push further. Oh, I just did paste such. So no need to do this again. Oops. Reconnection successfully. Good. A screenshot shows everything compiled and ran correctly. Rust compiled successfully, so finished release profile. Python loaded in the module. The radar heat map rendered. The pipeline is executing continuously. So your system is now RSSI acquisition, Rust Butterworth filter, Rust Kalman filter, Rust EWMA smoothing, motion energy extraction, Python radar heat map. This is already a legitimate RF sensing pipeline. Next stage would be breathing detection using FFT. Typical breathing frequency is 0.1 hertz to 0.5 hertz. So if it is there, we'll say he is breathing, meaning that 6 to 30 breaths per minute. So even a small chest movement slightly affects Wi-Fi multipath. Damn. So we detect this using a spectral analysis. Pipeline becomes something like RSSI, then Butterworth, then Kalman, EWMA, FFT, and then peak frequency. From there, we go to breathing estimates. So these are only estimates, all right? Yeah. So we'll create a new Python file, which is breathingmonitor.py. Let's do it. We'll create a new, well, first, let's see, Python app, say that. Yeah. So breathingmonitor.py is there. We use tk-agg, matplot. We are using numpy, matplotlib, desk from collection. We are using a Wi-Fi core, which is our Rust library that we've created. Buffer is 512. Right, we are running. So let's paste it and try running our I think I did not just copy it. Let's copy this. Let's run our breathing monitor.py. Will it open up? It will. So this is our breathing monitor.py. Breathing rate. Well, I'm breathing. Not just a small chest movement. I am breathing because I am alive. I'm speaking. So yeah, I think this is not working as we expected. So yeah, let's screenshot it. Let's paste that screenshot. I push architecture further. All right, we'll do that. So let's end this using Control C. We'll clear it out. And then we'll grab this signal. Yeah, we copied it. So signal is 49 dBm. Oh, so when I spam this command, how many times? So I'm spamming. Yeah. So it changes. How fast the signal value updates when you spam the command. This determines if we can push sampling to 50 Hertz or 100 Hertz. So let me move and then spam. So I am moving. So it is mostly giving us average of 50, 50, 50, 50. But if we don't, then still there is 50s. And I think one out of two is 50 most of the times. Oh, it is 45. It is settling down at 45. Again, back to 50. How many 50s are there? See, three 50s. Is it even sort of capturing my hand movement or what? I don't want to go. I don't want to know. And hence, this is why I love Rust and I use Arch, by the way. Why? Because, developing anything in Arch is fairly simple. We don't have to, well, we have to install a lot, but we don't have to configure all these paths and whatnot. Most of the libraries are well community driven, so we get it very easily. Good for us. So if you are into development, well, try running Arch Linux. It will be better. Excellent progress. So your screenshot confirms three important things. Rust filters are working like Butterworth, Kalman, and EWMA. FFT filter, well, it doesn't. Well, it doesn't, first of all. FFT pipeline runs correctly, breathing estimation appears, and RSSI updates from IW are slow and discrete, like 1 to 2 Hertz. From manual sampling, this indicates a Wi-Fi driver is exposing RSSI only when the link statics update, not at high frequency. So realistically, sampling rate is 2 to 5 Hertz. That is too slow for accurate breathing detection, but still usable. Next stage is Rust RSI acquisition thread. So new architecture is something like this, where we have a Wi-Fi card, then we use RSSI polar, is using thread. Then we say Rust signal pipeline and Python visualization. Benefits is that we eliminate Python subprocesses and lower latency, cleaner pipelines, prepare system for future CSI sensors. So step one is to create a RSSI Rust. Create a new file. What happens to the export function. Step 4 is to recompile. One important question. Wi-Fi CSI, which is channel state information. CSI gives subcarriers instead of one RSI values, enabling real Wi-Fi radar. So if I do, I guess it is Realtek. Yeah, I know what it's talking about. So it is talking about if I have ESP32 Realtek or something like that. So I have Realtek. How about we make it seriously based on trust only and use typing, but just user interaction and people. A new project and PEM. New one. Just a suggestion from my side. Let's not, you know, do our stuff with this project that has been already created. So let's not change it too much. Or C3 dash L to a 4. So, I still remember that what I have to. So RSI sensing is well supported. CSI sensing is not uh, in my real tech. So SSI sensing is there. CSI sensing is not there. Monitor mode or CSI hacks, well, not possible. That's what it says. So a system will remain RSI SSI based RF sensing, which is fine for motion detecting at activity sensing, presence detection, but not for high resolution RF imaging. RF, I am talking about RF, it is radio frequency, all right? So yeah, but still we can build a very clean architecture. Final system architecture will look something like this. Uh, Rust will do the sample RSI processing signals, produce feature stream. Python will only visualize, interact, and experiment. So step one, we have to now create another project. So we'll do that. How about we deactivate now? Deactivate this. Let's go back. Or should we? Well, I think we shouldn't go back. Let's create it over here only. All right. Now, if we not go back, just see what is there, previous directory. So we have VENVs, Rust core. So if we want to create a new VENV, we can. If we don't want to, well, we still can. Now it says we have to create a Rust engine. So we'll use cargo and it is a library. So we'll use a live flag. So we are creating cargo new Rust engine, which will create a Rust engine, but it will be of type library, not binary. So yeah. Now if I do tree, we should see tree exactly like previous one. Now we have to make directory of Python dashboard, which is well interacting with our app or our APIs or whatever this library is. Right, we do that. And then we have to create a new virtual environment. Now we don't have to upgrade our virtual environment because it will be a version, you know, whatever version that we created. We installed the latest version, no? We did install the latest version, which is 26.0.1. Ah, so we created a virtual environment. We even activated it. So if I see pip list, I shouldn't see much of anything. Pip list. Yeah, only pip is there. Which 25.3? Why is it 25.3? Like I just, oh shit. I think I have to, restart my PC or something like that. Make the changes possible. Or make it to 26.0.1, but it is installed. So I don't know what's happening right now. And let's install all these matcher and all that. Well, good for us because it used the cached one, so we don't have to install new one again. It just used the cached one. Good for us. Python M source pip install everything. So step 5. So we will organize Rust properly now. So we'll have a lib.rs, acquisition.rs, buffer.rs, filter.rs, kalman.rs, fft.rs, and features.rs. And each module will have a single responsibility. Let's do that. And for cargo.toml, we'll have to, well, before that, let's copy this and touch all these files. Let's see what I've created. This is why I sometimes think I need a new PC or something like that, because this is not anywhere powerful of what I'm trying to achieve and do. This has hanged now, so it is hanged. I've pressed few keyboards, key presses. That's not even processing it. It says pip install, upgrade pip. We'll do that. Let's see if it. If it uses cache, so it says requirement satisfied, already satisfied. Well, just install without using internet, I guess. It used the cached pip 26 version. Good for us. As for these, we have features.rs, fft.rs. Let's compare it to tree. All right, Kalman.rs, we have filters.rs, we have buffer.rs, acquisition.rs, we have touch. lib.rs is already there, so we don't have to create that. Let's go. Let's get into Rust and then src. Inside that, let's touch all these files as we just append our lib.rs to an empty file. Now if I do tree, we should see exactly same tree as this one. And the step 6 is to edit our cargo.toml. So replace dependencies section with these. Let's do that. Let's go back. Uh, let's use Vim for, Rust and cargo.toml. We'll go over there. We'll open up a new line, paste everything. We'll remove this dependency. Name for this library is RF engine. Create type is cdylib, and everything is there. Now, step 7 is, core engine concept. So Rust pipeline should look something like RSSI acquisition thread, lock free ring buffer, signal filters, features extraction, Python APIs. All right. So this engine will output things like motion energy, dominant frequency, variance, entropy. So Python will read these feature vectors. We still have 2 minutes from 9 o'clock. So step 8 is Rust main loop processing will look something like this. I know what it will look like. RSSI read Wi-Fi signal. So it will read Wi-Fi signals. Then it will push the RSSI to a buffer. Then, we filter it using Butterworth. We send the buffer to it. We estimate using, the filtered buffer. Then it's using EWMA. Kalman and EWMA function has been used. For spectrum, we use FFT and then send in the smooth. And for features, we send in the spectrum for extract features. And then that will send it back to Python. Step 9, Python dashboard. So Python only connects to engine, sorry. It just says RF and read features and then plots it. Step 10, what this upgrade gives us. Current system, well, Python heavy. Rust helpers. New system will be like Rust will be using the real-time engine and Python is just UI layer. Future extension is whatever. So important next steps before we should design Rust code properly, including lock-free acquisition. That streams 90%. I can show you very clean. All right. So what I will do right now, is there any tree? So let's do ls. Let's say something like tree. And I want a flag which, sort of doesn't use a show. Like if I do tree right now, it'll also show me all these VE and V's tree. So I don't want the VE and V's tree to be visible. So what I can do is, I guess, use a flag. I think I-I, which is VE and V. Then if I do this, what is it? It only gives me V and V's result. So I don't want this. So not like this. I want to ignore it. There's ignore case. Dash L can be used. What is dash A be used for? So if I say V and V, not variable, VE and V, but it doesn't ignore VE and V. Our dash I, capital I, V and V. Yeah. InV is set up. Now we just need to code. So our environment is set up and we just need to code. That's what I said. And then I pasted my tree. Let's go. So we will implement it in this order. So one, we'll create RSSI, then ring buffer, then filters, then Kalman estimator, then FFT, then feature extraction, then lastly Python APIs. And it says the cargo table should exactly look like this. It does look like this, isn't it? But doesn't it? Well, let's get into Rust first of all, and let's add the cargo. And it exactly looks like this. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5, 6. 6 is there. So we have to add a rayon. No, rayon is there. Regex is still there. Okay. Rust FFT. Rust FFT is there. Pio3 is there. Regex is there. Rayon is there. Crossbeam is there. So 1, 2, 3, 4, 5. 3, 5. There are only 5 dependencies. There are only 5. So yeah, nothing changed. Sorry. My bad. So nothing is different. Name is RF engine. Name is RF engine. Create type is cdylib. Cdylib. Just addition is different because, well, whatever. So now acquisition module. So we are now coding acquisition.rs. So let's see if it exists. It should exist in SRC. All right, there exists acquisition. So let's first of all change back to SRC directory. Now we'll directly name the acquisition.rs and let's paste the code. So this is our acquisition.rs and acquisition, no S. So regex standard process command. We say these. Well, we are creating a public function, read RSSI. Time is exactly 9 o'clock, 9:04. So I think we'll have to move on from this quickly because we have to, cover up our 13.9, Rust documentation. We are still in the learning phase. Ring buffer, which is buffer.rs, will look something like this. We'll copy this first of all. Copy it and we'll go to buffer. We'll paste it. This is our buffer's code. I'm not wasting my time explaining it because still it's new to me. Then for filters, we'll create filter.rs. This is our filter.rs code. Let's go filters.rs. Oh, this is great because it has two filters like EWMA, which is mostly same as Butterworth. I don't see much of a difference. Still no difference. Same formulas, alpha multiply x plus 1 minus alpha multiplied previous. Exactly the same. I don't know what is the difference between Butterworth and EWMA. I'll ask it later, but we still don't know this. So keep it in mind. We have to ask what is the difference between these two filters, EWMA and Butterworth. Because code-wise, I don't see a difference. Then we have to say Kalman filter, which is a different Rust file. So Kalman.rs. Kalman is also filter. Why didn't we include it in? Kalman. Let's exit. We'll create Kalman.rs. Let's paste it. So this is the code for Kalman filter. Signal, Q, and R, same as always. We have already implemented Kalman.filters. Now FFT.rs, it is also, I think it is same. So let's say vim and FFT.rs. We'll paste it. This is our code for FFT.rs. Now there are many shorthands like iter, map, norm, collect, and all that. These are all shorthands. So features.rs. Copy this. It got copied. Now we'll go vim features.rs. We'll paste our code. This is a features.rs code. There is mean, there is variance, there's energy, and feature is, sending out or sort of returning both variance and energy. Both are enclosed in function extract. Good. Now Python interface, which is lib.rs, Python APIs. We are opening up our function to Python. We'll create lib.rs, vim and lib.rs, paste it. So this is our lib.rs. If somebody wants to copy it, we'll just try typing it out. For later, I'll just create a documentary for this or a blog, something like that. Now compile engine. So inside Rust engine, we have to do this, mature and develop release. This installs the RF engine into your virtual environment now. So let's do that. Mature and failed. Can't find, what doesn't it find? Oh, since we are in SRC, let's clear it. How about now? Yeah. So from source file, we cannot do that. We have to go back to, yeah, inside Rust engine. So we go back, right? There. And then Python test, we have to create a test in Py. We coded something like this. See, in Python now. There's only loop that's running. We are printing RSSIs, and that's it. We are not even sending request to get RSI. Earlier, we were using I to def 1.0 from here on Python only. Now we are not just passing 1.0 as a device. That gets into Rust engine, which is our engine we created, into get RSSI, and it gets the RSSI quickly. After this, math.lib, something like that. So how it, and when you see my CPU usage is 100%. See, 100%. Damn. Now this is what I talk about, like using the whole compute. Like it was 100%. Damn. There are warnings because we have created functions, but we're not using them. So that's why I guess we are getting warnings. Doesn't matter. Let's go back. CD. Sorry. ls. Yeah. Wi-Fi to Python dashboard test engine.py, and we just paste this test engine. And then we just have to say Python and we run it. Isn't that great? So we are getting the browser hangs damn too much. If there is any alternative to browsers, I would love to accept it. But it should also work like browser, not just be a rather foolish alternative to browser. And we all thought something like, if terminal is so snappy and fast, why don't we use a terminal browser? But then browser is much more complex than just a simple terminal. Like it has image rendering, video rendering, uh, rendering HTTPs, but you HTTP or HTML rendering is present in a terminal too, but we can only render text as much. And if we try to make something like full-fledged browser in terminal, I don't know how that will go. But since we are learning Rust, we'll do that someday. Not today, but someday we'll do that. We'll create a Rust-based terminal-based browser. Terminal-based browser in Rust language. Yeah, that's appropriate. Everything is working correctly. The warning during compilation. Uh, this simply means that Rust compiled those modules, but nothing in lib.rs calls them yet. So that's why it says unused function. Later, the engine will call the Butterworth, Kalman, and EWMA. So these warnings will disappear. They do not affect execution yet. So Python test code is good. This confirms pipeline works. Now the keyboard interruption, well, I did it. Our current system state is, our status is somewhere near this. Next major step would be, right now Python does the loop call and Rust. That still gives Python control. Instead, we want Rust to run the continuous RF pipeline internally. New architecture would be Rust threads and all that. So we'll even loop not using Python but using Rust. Now this gives us lower latency, better stability, clean architecture. The current engine loop, well, it's just a concept, but Rust will run something like this. Python will just call the read feature and it will give it a loop. We will implement next is two new Rust modules will become central, which is engine.rs and stream.rs. Final layout looks something like this. The resulting system after this step, you will have a real RF sensing engine. But first of all, let me check if I've used all the created Rust files in SRC. So yeah, everything has a file size, so it means we have used all of them. Like I remember creating acquisition.rs, buffer.rs, features.rs, ffd.rs, filters.rs, Kalman, and library. So now we will have to add two more, which is engine.rs and stream.rs. So finally, the tree will look something like this. The resulting system would be like Rust is real-time signal processor and Python is just a dashboard. This is our system like robot perception, radar signal processor, RF sensing labs are structured. And before we continue, we should run this to sort of, we are watching for 0.1 seconds. So this is sort of a loop and we are grabbing the signal. Tell me, does it update every refresh? If it does, we'll just put this command in Rust. Or stays, so we'll see. Well, it's not doing anything, I guess. It's not showing me any result. So I had to end it. Oh, it says let it run for 5 seconds. So does it automatically closes after 5 seconds? So let's count for 5 seconds. 1, 2, 3, 4, 5. So now it is almost, running for 10 to 11 seconds. So it's not giving us anything. So I don't, oh, I don't see any output from this CMD. command. Let's paste that command. Oh, this happened because of the pipe that is grep signal is outside the watch command. Watch only runs, so we have to use something like apostrophe. Exactly. So we used quotes. Apostrophe is different, no? Quotes. Yeah, double quotes. I don't need much of explanation because I know what it does. Ah, now we are seeing signal which is changing very much. Should I screenshot it or what? Yeah. What you should see is a full screen terminal refreshing like something like this. Case A changes every refresh, RSI updates. Case B, the same value several refreshes. Yes, it does. It changes EVERY refresh mostly. Next step is important. Excellent. This is very good news. Your screenshot shows signal minus 44 dBm. And you said it changes almost every refresh. That means your driver is updating RSI roughly at 10 hertz, which is, every 0.1 seconds. Now, that is actually quite good for RSSI sensing. Let me check it again. Yeah, it sort of changes very frequently, doesn't it? Capability with 10 hertz sampling is very good, very good, very good, and all that. Borderline breathing detection and gesture sensing, which is possible, but there's a warning sign, so warning but possible. Next stage is Rust RF engine. Instead of Python calling Rust repeatedly, we switch to, all right, step one is to add this in our SRC, which is engine.rs. Let's copy this instead. We go into Rust SRC and we say ingine.rs. I don't think there is any S. Engine.rs, exactly. It's not engines.rs, it is engine.rs. This is our code. Public step, and then the step is something like this. All right, printing motion. Then we are running it. All right. Close it. Step 2 is to update lib.rs. Replace content with